Good afternoon. Can you hear me at the back? Yes? Okay, thank you. I want to thank you for joining our speaking event today on climate change. And at the outset, I'd like to acknowledge members of Regional Council who are here today. Councillor Downey at the back here, and Councillor Shaughnessy. So thank you both for joining us here today. In the Region of Peel, achieving better environmental outcomes and addressing climate change is a term of council priority. Together with our community partners, the region is committed to leadership and action that will mitigate and adapt to the effects of climate change and lead to a sustainable community for future generations. We are honored today to have Dr. Dianne Saxe, the Environmental Commissioner of Ontario, with us to help build our knowledge in this important area. Dr. Saxe was appointed as Ontario's Environmental Commissioner in December 2015. She was one of Canada's most respected environmental lawyers, with over 40 years' experience writing, interpreting, and litigating Ontario's energy and environmental laws. Dr. Saxe will present evidence on climate change, and which I hope will inspire you to get engaged in reducing the impacts of climate change in our local communities. Please join me in welcoming Dr. Dianne Saxe.
Hello, and thank you very much for coming. Everybody at the back, you can hear me? Yes? Okay. So let's see if I can do this. Look at that. This is what I'm going to try to talk about, a little bit about who I am and what I do, why climate change is everything, a bit about what Ontario is doing, and a bit about what you can do. Challenge always is that I have so much I'd like to talk to you about and not enough time. So there's far more slides in this deck than I'm likely to get through. Sorry for those of you who's back. I don't have a chair to sit on, so if you don't like it, maybe move over there, or I'll try to turn around. But if you want a copy of the presentation, because there's a lot of good slides on here, Mark, where is Mark? Mark at the back. We'll have the presentation available for people. And there's also some webinars on our website that you can watch anytime you like. There's 2 on the climate report alone and 1 on our new energy report, which deals with water and wastewater systems. So briefly, who I am and what I do. I am an independent legislative officer, so I have the privilege and the challenge of being nonpartisan but not neutral on issues on which the 3 parties that I serve disagree. So I report to the Speaker, and through him to the MPPs, and through them to the people of Ontario, and my job is to provide a nonpartisan, reliable take on the 2 areas of my responsibility. First, I'm the guardian of the Environmental Bill of Rights, which is a series of tools for public participation in significant environmental decisions. And on the back outside, there was a little pamphlet on, with a basic introduction to the Bill of Rights. And secondly, I'm required to report to the Speaker and to the legislature on 3 quiet little topics: energy, environment, and climate. So we write reports. We work very hard to make them really good reports. They are all available on our website. I brought executive summaries of most of them with me today. They are available outside. They can all be downloaded in both official languages. And if you need hard copies of either the executive summaries or the reports, again, let Mark know. We'll be glad to send them over. We also have a really good alert service on our website. If you want an email to come to your website when the government posts notices or decisions on things that interest you, it's impossible to do through the government website, easy to do through our website, and free. If you're interested, ask me afterwards. So basically, I'm here to talk a bit and quickly about climate and why I think it changes everything, why it does change everything. Please don't stand at the back. There's lots of good seats at the front, and I don't throw buns. But basically, if you don't remember anything else I said, there's the summary of it. It really is so much worse than most people think. And it's one of the things that's really driven me as commissioner. I was an environmental and energy lawyer for 40 years before I became commissioner. I thought I had a pretty good sense about climate change, and I knew it was big, and I knew it was bad. It was going to be bad for polar bears, and it was probably going to be bad for other people in other places later. But I did not realize how much was here already and how much damage it is going to do in my lifetime and the lifetime of my children, not to mention my grandchildren. So the first thing I ask everyone to do always is to think about some young person you care about. These 2 particular ones I'm rather fond of, despite the number of times, they've thrown up on me and that kind of thing. But There must be some young person you care about, because this matters to us, but it matters a heck of a lot more to them. So keep that person in mind. How many of you have occasion to talk to friends, family, neighbors, colleagues about climate change? Yeah? A few of you? Would you find it helpful to have some nonpartisan, reliable facts to use in these conversations? Okay, well that's what I'm here to try to provide. Now we are much better, we are very lucky to be having this conversation in Canada and not in our neighbor to the south. But it's still useful to remind people that virtually all climate scientists agree on the basics. There's lots of room for argument about the details. The details of climate science are very complex, but the basics are simple, and they're clear, and they're really well understood. Climate change is caused by us. It's serious. It's real. People may not understand the mechanism very well. Basically, what greenhouse gases are like, it's like having hair in the drain of your bathtub. Okay? So if there's 1 or 2 hairs in the drain of your bathtub, nothing much changes, right? But if you get 100 hairs, if the hairs keep building up, the hairs keep building up, and you keep pouring more and more water in the bathtub, what happens? Right? Greenhouse gases are like that. The sun's heat keeps arriving, but it can't escape anymore the way it used to. And if the heat can't escape, it builds up. That's the basics. It's not complex. What people don't usually realize is how fast it's moving, how much it's already here, and how enormous the economic implications already are. So if you look at this chart, you can see in 1992, when I went to the Earth Summit, and all the countries of the world agreed, even the oil-producing countries, that carbon dioxide is the most common greenhouse gas that we create. Greenhouse gas is a very significant human health, economic, and environmental problem, and we urgently had to reduce our emissions. That was 1992. What have we done with our carbon dioxide emissions since then? Right? This has all happened in my lifetime and in most of yours. So where does the carbon dioxide go? We humans are putting carbon dioxide into the atmosphere faster than has ever happened before, ever. So where's it going? About a quarter of it goes into the ocean. That's acidifying the ocean. That is damaging the ability of everything that lives in the ocean to, for example, build a skeleton, damaging the basis of the food chain, many other things. About a third of it's gone into soil and vegetation. That's good. It's growing trees, and so on and so forth. The problem is that it leaks. It's very hard to keep carbon in soil and vegetation. It's easy to put carbon into a tree when you grow it. When you burn it, you get it back. You turn that tree into diapers, you get it back. It's fairly easy to put carbon into soil, but you warm up that soil, you get it back. So we have this enormous amount of carbon that is in an insecure storage in soil and vegetation, and all the rest of it is in the atmosphere. So, unsurprisingly, carbon dioxide in the atmosphere is at a record high. Now, you've probably had people talk to you about natural cycles. There are lots of natural cycles. The world's climate is affected by lots of natural cycles. Anybody think of some natural cycles? Yeah. Solar variation, right? The sun's radiation waxes and wanes in about an 11-year cycle. There are orbital wobbles. The Earth's orbit is not perfectly even. There's precession of the orbits. There are volcanoes, right? There's all kinds of natural cycles, ice ages that come and go. But over the last several million years, carbon dioxide has always gone up and down in a very narrow range, 180 to 280 parts per million. And we blew past that in 1860. Now, you'll see 350 in red on this chart, and that's because 350 is our best guess as a magic number. It's the highest level of CO2 that we can have in the atmosphere for long and still have the kind of world that existed when I was young, with coral reefs and mountain glaciers and low-lying island states and Miami and Bangladesh and that kind of thing. But it takes about a generation between the time that we put carbon dioxide into the atmosphere and the time that we really start experiencing the climate effects. So here we are about exactly a generation after 1988, and what is happening to coral reefs around the world and mountain glaciers? and water level in the streets of Miami, and wildfires. And we're now permanently over 400. This year we hit 410. We're now permanently over 400. Well, permanently, you know, from my life and my kids' life and my grandchildren's life and their kids' lives probably, and after that I don't know that I care. Now, nobody can tell us exactly what that's going to mean, because there have never been humans when carbon dioxide was over 400 parts per million in the air. And there has never been a time in the history of the Earth, as best we can tell, where carbon dioxide has increased this fast. So we are in completely uncharted territory. But we do know that roughly a quarter to a fifth of the carbon dioxide that we've put into the atmosphere today will still be in the atmosphere trapping extra heat 1,000 years from now. And we know that it's going to be about a generation before we start experiencing the climate impacts of being over 400 parts per million of carbon dioxide in the air. Now, it's not just carbon dioxide that's gone up. This is carbon dioxide, methane, and nitrous oxide. And if you look and see what's happening, what's trapping the heat these days in the atmosphere. Now, hopefully that's the same color. Oh, good. So you'll see the turquoise part. That's the amount of extra heat that's being trapped by carbon dioxide. It's about 2/3. But there's lots of other stuff also trapping extra heat. So the next one's methane. That's mostly from animal agriculture, from waste, and from oil and gas. Next after that is nitrous oxide, mostly from agriculture, also from chemical plants, and almost the entire rest of it is from refrigerants. And refrigerants, many of them thousands, tens of thousands of times more powerful than carbon dioxide at trapping heat, and likely to stay in the atmosphere for tens of thousands of years. So what we do for our short-term convenience has really long-term consequences for us and for everyone who's going to come after us. So this is last year, highest temperatures in human history, in recorded human history anyway. The dark red is record temperatures. We blew away records for temperature records all over the world last year. Might do it again this year. There's only a few places in the world that were cooler than average. You see those little blue spots? Do you know what you're seeing? That's the ice caps melting, putting a lid of cold, fresh water on the oceans, which itself interferes with the way the ocean currents move. And if you look, you'll also see that the high Arctic has some of the highest temperature records. And what that means is that the temperature difference between the Arctic and the equator is changing. And that changes how the winds blow. So Canada was notorious worldwide, I am told, on good authority, among weather people for having had hit-and-run weather. That is, weather systems would basically move across Canada on a conveyor belt. We'd have everything for 3-ish days, and then we'd be on to the next thing. And that's been driven by the jet stream. And the jet stream has been driven by the temperature difference between the Arctic and the equator. But we've changed that. And so the jet stream doesn't behave the same way anymore. The jet stream is slower and wavier, so weather can get stuck longer. So if we have a hot weather system, we will have it hot longer. If we have a cold one, it'll be cold longer. If we have a wet one, it'll be wet longer. If we have a dry one, it'll be dry longer. That's not good for agriculture. Now, where's all that extra heat going? Now, those of you with good eyes or those sitting near the front, you can see that near the bottom of this chart on the left, there's a little wee red line. Can you see that? Some of you see a little wee red line at the bottom of the chart? Okay, well, those who can't see it, just take my word for it. There's a little wee red line at the bottom of the chart. All that extra heat that's being trapped, only 1% of it's in the air. That's the red line. So the stuff that we're noticing when it was 17 degrees in February, that's only the red line. The green one is what's in soil and vegetation. The white's what's melting ice. All the rest of it, about 93% of that extra heat, it's in the water. It's in lakes and oceans. Now, what's the first thing that does? You probably learned in grade 3, and it's on the slide, so there's a clue. Warmer water takes up more space. It also holds less oxygen, which is why warm water fish are different from cold water fish. But it takes up more space. So if you put more heat into the ocean, what does the ocean have to do? Take up more space. It doesn't matter whether you believe in it or not. So if you melt an enormous amount of ice and heat the ocean, we have to have higher sea levels. And in fact, sea levels are increasing and are increasing faster and faster. And not only that, we have to have wilder storms because storms are heat engines. Heat engines feed off the heat in the surface of the ocean. The more we heat the ocean, the wilder the storms have to get. And so it's no coincidence that the strongest storm ever recorded to hit land was in 2013, and the strongest sustained winds ever recorded in a hurricane were in 2015. But remember, only 1% of the heat's in the air. Now, if you look at this chart, you'll see it does not look like the greenhouse gas chart. Remember, the greenhouse gas chart looked really smooth. It's getting steeper and steeper. Carbon dioxide increasing in the air 2.5 times now as it did in the 1990s, which is not that long ago, but it's quite predictable and steep. Temperature is not predictable. Why is that? Because the greenhouse gases, climate change is being added to a temperature system, a world climate, which is chaotic and unpredictable. So if you think about a dog with a really long tail, right? If you focus on the tip of the dog's tail and the tail thwaps around a lot, that's like paying attention to the temperature. This, by the way, is the average temperature of the entire world, right? It's a pretty big place. So even individual places are going to have even wilder swings. But the other end of the tail is attached to the dog. And the dog is the greenhouse gases and the extra heat that we're trapping. So the more heat we trap in the world, eventually air temperature has to go up because the heat can't escape anymore, and you can see that's exactly what's happening. Now this is one of the most important slides I've got because, you know, what I'm giving is really bad news. I know it's really bad news. I wish I had something else to say. And when you're faced with really bad news, the natural tendency of most people is to want to hang on and wait for it to get better, to wait for normal to come back. And normal cannot come back anymore. Now, I'm a lawyer, so I'm from an evidence-based profession. How many people here are from evidence-based professions? A few people willing to say that, all right? So there's a big issue about the evidence-based professions. There's only one place to get evidence. It's what's happened already. And lawyers in particular look back. Lawyers, actuaries, engineers, crop designers, and so on. They tend to look back. And roughly, our laws and standards and infrastructure standards are all based on the averages of the 20th century. And the average of the 20th century is that 0 line on that chart. We don't live there anymore. And it cannot come back because we are a generation behind, right? It will take us another generation before we feel the effects of the carbon we have already released. We are trapping extra heat every day. The average of the 20th century can no longer come back. If you look at the chart on the right, it's sort of a schematic. The lower green line shows you what we're already experiencing. The upper green line, what we have already locked in from what we have already emitted. Not just the fact that we're continuing to run our economy 80% on fossil fuels. That the world economy still runs 85% on fossil fuels. This is just what we have already emitted. Now, people talk about global warming sometimes. You won't hear me talk about global warming because it leads people to think that Senator Imhoff walked into the Senate with a snowball. See, it's cold outside. Global warming is a hoax. People tend to think that global warming means that everything is always going to be warmer, especially when you want it to be. And it's not like that. Climate change means higher average temperatures, but they are unevenly distributed. And one of the biggest things it means is more extremes. So the old joke is if your head is in the oven, you've got third-degree burns, and your feet are in the freezer, and you've got frostbite, on average, how are you? Right? Everything I showed you so far is about the averages, but what we're getting is more and more extremes. So you see the picture on the left? That's a road melting in India a year ago. This is, it means when, not if, for all kinds of changes in Ontario. Wetter springs, faster melts, hotter, drier summers, storm floods, droughts, forest fire. We know we're going to have more extremes. Now, it's not just me saying so. Those wild, crazy people, the actuaries, we in Canada, the United States, were some of the luckiest people in the world. We already have triple the extreme events that we had when I was young. For those mathematically inclined, we're already at 2 standard deviations. on extreme events. That shows up in catastrophic insured losses. This is just dollar, this is constant dollars, there's no inflation in this, and this is just the insured losses. You have to assume, the insurance companies tell me, that actual losses in each case will be about twice as much, because only about half of all losses are insured. Do you think this will affect the cost of your property insurance? Do you think this will affect availability of property insurance? Do you think this is changing the conversation among the insurance companies and the reinsurance companies about what is going to be available and for how long, especially in places with high loss ratios like Alberta? And how much worse is it going to get? Well, everything I've talked to you so far is about measurements. I know what's happened already. In terms of what's going to happen, I don't have a crystal ball. We have to turn to computer models and try to figure out, well, what's ahead. This is the best computer model we have for Southern Ontario, done out of York University. And I know it's too optimistic because it's based on the assessment report of the Intergovernmental Panel on Climate Change. And if we get time, I'll tell you why I know it's too optimistic. But even this said, all right, best case, if the whole world did everything right starting 5 years ago, we'd be really lucky to stay under 2 degrees. Who thinks that everything right has been done by the whole world since 5 years ago? Okay, and if we don't, where are we going? What's it going to be like here? I do strongly recommend that piece in the New York Times about the uninhabitable Earth. Yes, it is absolutely terrifying. I did tweet it out with the annotations today if you want to look at it, possibly yesterday. But nobody can tell us what it would be like in Southern Ontario if we just continue the way we're going. A hell of a lot different. Enormously expensive, difficult transitions. Now, we do look, however, around the rest of the world, and we can be pretty sure that everybody else is going to be worse off than us. This is some work done by Solomon Shang out of the Berkeley, and he's just looking at temperature. This is not loss of the ice roads. This is not invasive species. This is not war. This is not water stress. This is just temperature. How much impact is there likely to be on GDP per person just from temperature? Now, in Canada, we're not going to have to spend as much on heating. So we're going to have some financial savings on average. But look at the rest of the world. What do you think will be the geopolitical effect of the average American having 5% less GDP by 2050, which isn't very long from now, just from temperature? Or China, down 7%, or India, down 37%, or more than that in the hot countries of South America, Central America, Africa, the Middle East? Do we think those folks will just sit there and leave us here in our splendid isolation with Great Lakes and still able to grow food? Do you think they might notice that we have been some of the largest emitters in history and some people who have suffered the least climate damage? I can assure you the other countries are noticing. And because emissions have skyrocketed, and yes, you saw that slide before, and because they're still growing, so renewable energy is growing at double digits, which is great, but from almost nothing. Look how much coal has grown in the last 15 years. Yes, it's leveled off thanks to China, but it's enormous. So you put all that together, and if we wanted a 2/3 chance of staying below 2 degrees, because we know that they're 2 degrees is the best work we have from the Intergovernmental Panel on Climate Change, means enormous difficult changes with millions of people on the move, but it's still more or less a recognizable, manageable world where we can probably still feed the population. If we actually wanted to hit that, most people think now we've got less than 5% of chance of hitting that, but if we wanted to hit that, most of the fossil fuels that are trading in the world stock markets now can never be burned. Maybe we could use them for other stuff, plastics, whatever, but we can never burn them. So we're in a situation where we cannot continue to have both the economic system that we have and the climate that we have. We can no longer have both. And then there's the question of what else we've unleashed, right? We still could, theoretically, humans could stop burning fossil fuels tomorrow. I mean, practically no. But in theory, we humans could stop that. But we can't stop the feedback loops that we're triggering in the natural world. So my whole career, I mentioned I was a lawyer 40 years, and I worked with all kinds of policymakers, and every policymaker I ever knew always had their desk full of emergencies. Every policymaker I always knew, especially the senior ones, was always working as hard as they could work. And climate change was always something that was big and important, and we'll get to it soon, but we really got to deal with this emergency right now. So at what point are we going to wake up and say there is no greater emergency anymore than this? Everything else on my desk is less important than this. How would we know when we got to that point? What will it take? How would we know if we were in a tipping point? And I think it might look something like this. So what you're looking at here is a summary chart of all the global sea ice measurements ever taken. Now you can see that, there used to be more sea ice. This is not a surprise. And this is not sea ice mass, right? This is not how much ice. This is coverage. How much of the Earth's oceans have ice on them. And that's tremendously important from a feedback loop point of view, because when sunlight falls on ice, what happens? It's reflected. When sunlight falls on water, what happens? It's absorbed as heat. So the more we melt the ice, the more heat we absorb. The more heat we absorb, the more ice we melt. The more ice we melt, the more heat we absorb. Now this is not in my climate report, because we had to put our keyboards down on that climate report in September of 2016. And it was, for the first time ever, as far as we know, in human history, it was in September of 2016 that the pattern of sea ice in the world changed and broke. There were temperatures from 30 to 60 degrees above normal in the Arctic last winter. And the sea ice continued to melt, which has never happened before in human history that we know of. So people always ask me, well, is it too late? And I have to say, well, too late for what? Is it too late for that young person that you care about to have the same world and the same options and the same future that you had? Yes. Is it too late for Ontario, Canada, to avoid having really difficult choices ahead of us? Yes. Is it too late to make a difference in what's coming? No, we're in that moment right now. There's a window. It's not a long window. 5 years, maybe 10. But we're in it right now. So Ontario is doing a lot right. We've got the coal plant closures. We've got cap and trade. We've got the action plan. There's a climate-ready update theoretically coming. We've got the new Climate Act. And I'm just going to skim through these slides so there's time for some questions. So there is a lot that's being done that's right. But there's a huge amount still to go. So if you look at this, this compares Ontario's emissions 1990 versus 2014. We had a target of being 6% below 1990 by 2014, and we made it. But we only made it for one reason. It's because we closed the coal plants, and also because industry used less. The big primal sin for Ontario is land use and transportation. Transportation is our largest and fastest growing source of greenhouse gases. It's almost entirely from petroleum products. We have the lowest car occupancy rates on our computers. We have some of the longest commutes in Canada, lowest occupancy rates. We have built Southern Ontario assuming that we will never run out of land and that we will never run out of petroleum, and that there are no consequences to burning it, and those things were wrong. And so to change that, to find a way to continue to grow our population. We're planning to add another 50% of the population of Southern Ontario in the next 25 years, and we've got good reasons to think there'll be a lot of people around the world to be wanting to come here. And at the same time, we've committed to reduce our greenhouse gas emissions 80%, and we have no idea how to do both those things. If we get to it, I can talk about cap and trade. There's some slides here if you're interested about how cap and trade works, which I'm kind of skip for now, where the money goes. There is a lot of growth going. I mean, there is good stuff happening around the world. Renewable energy is growing double-digit rates. As I said, there's lots of opportunity for efficiency. The International Energy Agency is estimating that basically, a third, 40% of what we need can be got from improving efficiency. And the good news for Ontario is, because we are some of the most wasteful people in the world, we have tremendous opportunities to be much more efficient and still have really good lives. Right? You've got to look at that. If you look at this, you can see that on average, about 2/3 of the energy that we use does nothing useful at all. Think about driving a car. All that energy that goes to moving the car itself and not you, that's all wasted. You didn't need to move the car, you just needed to move yourself. So if we rethink stuff, there is actually a lot of room for efficiency improvements. And municipalities matter a lot. Lots of things that municipalities do, land use being the most important. I brought a series of our reports. They're in the back. They're also available on our website. We've looked at a lot of the different things that municipalities do. Transportation, I've talked about already. Energy intensity. It is amazing, actually, now that we have data about how municipalities and other public sector buildings use energy, how enormous is the variation. Or one way of looking at it, how very inefficient a lot of the buildings are. And so we know that there's a lot of room for improvement, save a lot of money, and if everybody was able to get to basically the top quartile of other buildings like theirs, municipalities could save about $450 million a year. It matters that we pay attention to what we build and how we pay for it. Almost 40% of municipal energy use goes into water and wastewater, and a lot of those, it's remarkable how inefficient those plants are and how slow they've been in improving efficiency. Municipal water and wastewater plants have improved their efficiency only 1/10 as fast as the average Ontario consumer, even though they have many more opportunities to be more efficient. Lots of opportunities there. And anyway, lots of stuff about that in our report. So we really do, now that the federal and provincial governments are offering billions of dollars for reinvestment in municipal infrastructure, particularly water and wastewater, there's a once-in-a-generation opportunity here to really do something about that. But that requires reprioritizing what matters to us the most. A batch of examples of that. I do like this slide. So when I try to look at solutions, okay, for those wondering, no, there are no toilets on the bus, right? That's not what this picture is showing. Right, if we want to move away from fossil fuels, again, there's really only two choices. You can either improve your, three choices. You can do without, get more efficient, or find sources of energy other than fossil fuels, right? Those are the only three choices. So if you look around to say, okay, well, what sources of energy do we have that we're wasting? Well, you'll be delighted to know that human poop, has actually quite a lot of energy that we almost always waste. So a number of municipalities in Ontario are trying to do something about that, and there's about 3 dozen municipal sewage plants that digest their sludge and get biogas from it. About a dozen of those make good uses of the biogas, and one of them, the City of Hamilton, actually takes the biogas and they put it into their buses and they run their municipal transit system with it. But Hamilton is much too polite to paint that on the buses, so I used a picture from the UK because they're not as prudish. So there you go. Lots of things in new municipal asset management regulation. It's going to require municipalities in capital budgeting to look at energy, not just initial capital costs. That should mean better decisions over time. So, and there's these new municipal powers to adopt bylaws. This is brand new. I badgered the Ministry of Municipal Affairs to do something about this. They put it into the Municipal Act. You now have new powers to adopt bylaws about climate change and energy planning and tree preservation. And now it's a question to see who will have the initiative to do good, innovative, powerful things with those powers. So there you go. Knowledge plus action equals hope. We have to start by paying attention to the facts, even if we really don't like the facts. And I really don't like the facts, but they're still the facts. So the only way to get hope out of those facts is to find a way to do things together, to take action that's meaningful and to do it now, because we don't have any more time. Thank you. So I've got 15 minutes or so for questions. I'm told to make sure people speak their short questions, please, and directly into the mic, and maybe introduce yourself when you ask your question. Anybody have any questions?
Hi, my name's Jennifer Diaz. I just have a question about the coal plants, and I don't know, I'm certainly not sure even what I saw, but I thought I saw something about the actual amount of reduction isn't as big as they were expecting, and maybe that was a media thing, but they sort of alluded to the fact that what we perceived to be the particulates in the air was actually coming from the south, coming up from like Pittsburgh.
Right. So let me answer that. The Fraser Institute put out a report saying, forget it, right? Coal plants aren't important. And one of the reasons they need to do that is that anybody know how many smog days we had in Ontario in 2005 when we had all the coal plants running? Anybody know? 53. 53 smog days. My husband had asthma. Those were brutally difficult days. How many smog plants did we have in how many smog days did we have in 2015? First year that Ontario had no coal plants. 0. Now, not all of that is from Ontario's coal plants. We closed our coal plants, and they're right here. So they affected our air right here and everybody down with them. But it's also true we're downwind of the US Midwest. And the general rule of thumb is about half of the pollution that we're breathing is coming from the US Midwest. Anybody know how many coal plants have been closed or committed to close in the United States since 2010? 251. So our air is much cleaner, and of course other things happened at the same time. Drive Clean reduced pollution from vehicles, Ministry of Environment work reduced pollution from some industries closed, right? There's a lot of other things happened at the same time, but that was a very political report to make a very political point. Closing coal plants, absolutely no question, relevant to air, but it wasn't the only thing. Okay. Good question though. Thank you for asking.
Thanks, Mark. My name is Joanne Pattison. I have a question about our municipality. I'd like to see that our municipalities now have a bigger role to play. We live in a municipality where we have an international airport. Trucking is one of our largest industries. We have a diverse population. We have a wastewater plant, and we have the lake right at our doorstep. What would our municipality consider doing as our biggest game changer in your mind?
Well, I think probably your council and your staff know that better than me. I think it's always helpful to start with data. I do know that for Ontario as a whole, transportation is the biggest and fastest growing source of our emissions and the hardest nut to crack. So focusing on transportation is really important. Again, the good news is there is lots of evidence that if you give people alternatives to being stuck in long commutes by themselves in a car, lots of people will choose those alternatives if they have them. One of the fun things in Toronto is we now have bicycle traffic jams. I mean, I used to be the only person at the stoplight. Now I'm waiting behind 15 people to get through a stoplight in my bike lane. And of course, we now have 3 people dedicated to enforcing the bike lanes so that we don't have as many idiots parking their trucks in the bike lanes, forcing us out into the traffic. And the safer biking becomes the more people bike. The more people bike, the more people like biking. Jennifer Keesmaat keeps tweeting that all the largest sources of death in the North American population can be made better by cycling. So that doesn't work for everybody in every place, but if you look for the things that do work, and also multimodal active transportation. One of the things that I saw in the UK a lot and also in the Netherlands is a lot of people will bike to the bus, the train, the whatever, fold up their bike or park it, hop on the train and go wherever they're going. And that's been much less common in Canada, but actually, as somebody who cycles almost all year round, yes, there's some time in the year that I prefer to take the TTC, but a lot of the year, and of course climate change is making the winter warmer, a lot of the time I can cycle. So where that's possible, active transportation is a good thing. Trucking is a huge, huge area, and it's one of the most difficult to deal with. Emissions from trucking is the only part of the Ontario economy that GHG emissions are actually double now what they were in 1990 and continuing to grow. So there is a lot of work going on trucking, but again, Peel would be really well placed to to work on that. Some of that's about making the trucks more efficient. Some of that's about making the logistics more efficient. Some of that might be about having big trucks with diesel engines only outside the center of the city and having smaller electric vehicles inside the city for local distribution. California's doing some really good work on this, but it would be a great place for Peel to be a leader. It's a huge problem everywhere. But don't forget your sewage plant.
Hi, my name's Jonathan Kumaris. I'm wondering how you can change public perception around renewable energies. For example, my cottage is in Prince Edward County, and every time I would drive the cottage, I'd be so disheartened when I'd see all these signs on people's lawns saying no windmills in my backyard. And they actually shut down the windmill program that I believe was going in that area. And a lot of the locals I spoke with were very adamant against it. So I'm just curious how you can maybe change how people think and realize that we need to find other ways to produce energy.
Yeah, it's really interesting. Ontario has the dubious distinction of being the world hotbed of anti-wind sentiment. There is a very powerful nocebo effect, the opposite of placebo, and it turns out the nocebo effect, making people think that they are experiencing something bad, is 3 times as easy to induce as the placebo effect and takes 3 times as long to get rid of. So to some extent, I have some optimism that as people actually live with wind turbines and don't get sick, they say, oh, wasn't it bad? It's also true that as solar becomes so much cheaper, there is, so solar is growing very quickly. Now the Chinese are primarily responsible for this. They single-handedly basically drove down the cost of solar by about 80%. They put $50 billion into taking over the world's solar manufacturing over a fairly short period of time. And when you can just put tiles on your house and get your electricity supply that way, and you had to tile your house anyway, well, there are more options. I think that the one piece of research that we do have and have had all along is that when people make money from wind turbines, magically they don't bother them. And we did things wrong, and in Germany, the majority of the wind turbines are owned by community cooperatives. And so the local community is making money from the turbines as well as getting jobs from the turbines, and they're very pleased with them. Farmers are very pleased with them because they give them steady, reliable income, doesn't get affected by the commodity cycle. In Ontario, our legal process for approving them became so difficult that the cooperatives couldn't afford it. And as the former president of a wind cooperative, I could tell you more about that. So it may just take time. It may be that that's not the most important thing to work on right now. I don't have a magic answer. But if we can talk to people about other things, energy efficiency, reducing their energy bills. Lots of people in rural areas are very concerned about their energy bills. There are other ways to reduce our footprint, and maybe those are better things to talk to those folks about.
Hi, great presentation, thank you. On mitigation, I was just wondering what your key messages were on adaptation, since you said climate change is already here.
Yes, so one of the slides I didn't have time for, basically what I recommend to people, families, organizations at every level is three key things. Number one, figure out your carbon footprint and reduce it 5% every year. In Ontario, Project Neutral has a really good calculator, but that's the best rule of thumb for everyone at every scale. Individuals, families, companies, communities, regions, figure out your greenhouse gas footprint, cut it 5% every year. The second thing is to get ready for what's coming. So we know it's going to be warmer, it's going to be wilder, there's going to be more disruptions, there's going to be more power losses, more floods, all of those kinds of things. So that means making what you care about more resilient. You remember all the crisis last year about hot portables, the kids basically frying in the portables. Well, we didn't used to have extreme heat in September, and so we didn't build schools expecting kids to have really hot Well, we know we now will. So we have to have some way of what are we going to do about those portables? Are we going to put green roofs on them? What are we going to do so the kids don't fry? Think about flood prevention at your house. So figure out what you're most vulnerable to and do something about it. And then all that old stuff that they always say, the medical officer of health always says, have 3 days worth of emergency supplies at your house. Do it. Right? This is time to do it. And the third thing, and maybe the most important thing, is to speak up. Canadians tend to be very polite, and we always tend to assume that if we know something, then everybody else already knows it, and that someone has already spoken up about it. And so also we tend to assume that if we don't hear anybody else talking about stuff, no one else is doing anything. And being social animals, we don't tend to do things if we don't hear other people doing them. So one of the most powerful things that people can do is speak up about climate issues, be public about what you're doing, and speak to your political representatives. Now, I know there's a couple of councillors here. My experience with politicians, I spend a lot more time with politicians these days than I used to. They care enormously about what their constituents say to them. Right? So, if all they hear about is complaints about electricity prices, what do they think is the most important thing? How many people here have spoken to your political representative about climate change? Okay, there's a lady here to emulate, right? It is incredibly important, and be creative about it. So one of the councillors in Toronto was talking passionately about how much it influenced him that he got a whole box of Valentines from a grade 3 class asking him to support climate activity in Toronto, climate policy in Toronto, and how much that meant to him. So be creative. Go speak to someone. But not just you. Your sewing club, your bowling club, your mother's hockey league, whatever. Get the groups together and think of an innovative, hopefully kind of fun, upbeat way of going to your political representative and say to them, what are you doing about climate change? What else could you do? What's getting in your way? Can we help? Right? And then do some of those things and tell your neighbors, because that's the most important thing that you can do. So thank you very much, everybody.
So, Dr. Saxe, thank you for that presentation. I think for all of us, very compelling in terms of the evidence. You've given us a lot to reflect on as an organization, and I think we're well positioned in Peel as we're creating our master plan on climate change. It's an opportunity for us to address some of that evidence. So, as a token of our appreciation for you speaking today, we will be making a donation to an environmental organization of your choice. And as we end our speaking event today, I'd encourage everyone to visit the tables and displays in the main lobby to learn more about climate change. So I hope the information you heard today will compel you to take action individually with your families and as part of the Peel region. Thank you.